so we just balanced our equations for the first time. What did we have to do? What were we trying to follow when we balanced?
Well, we had to wrap.
We had to wrap.
And we had to make sure that my law of conservation of mass applied, that nothing was lost.
How did we know that?
Gained.
How did we know what had to be true on both sides?
They had to have the same number of atoms on both sides when we wrapped.
Right, because we can't create or destroy atoms. And then what was the only thing we could change about our reaction?
Coefficients.
Coefficients. And which were our coefficients?
Big numbers!
Big numbers in front. So that's the only thing you can change. So now, if you're pretty good with what we're doing here, stop the video, go try the guided practice on your own. If you get a little stuck, come back. If you're still kind of confused, we're going to do the guided practice. So stay with us. All right. So our first guided practice problem, we are looking at methane, which is CH4, reacting with oxygen to give us CO2 and H2O. This, by the way, is a combustion reaction. What does combustion mean?
Boom!
Burning! We are setting things on fire. And so it's still going to balance the same way. So what do we have to do first?
Wrap.
Wrap. We're going to do our atom inventory. And so what atoms do I have?
C's, H's, and O's.
And every single time you have a combustion reaction, you're going to have C's, H's, and O's. That's how it works. How many C's do I have?
1.
Okay, on my reactant side I got 1. How many H's?
4.
How many O's?
2.
Okay, on my product side, how many C's?
1.
How many H's?
2.
How many O's?
3.
3. Okay.
That's 2 and then plus 1 on the...
Right, because I've got 2 in my O2 and then 1 in my water. So what doesn't match?
H's.
H's don't match. What else doesn't match?
The O's.
Which one do we think is easier?
H's.
H's. Yeah, never try and balance something first where that shows up in more than one place. O is going to have to get done last here. So my H's don't match. We got to do my H's first. So what do I need to add to my product side so my H's match?
I need a 2.
I need a 2. Where do I put the 2?
In front of the H2O.
In front of the H2O.
So 2 times 2 is 4.
All right. What else does that change?
My oxygens.
Your oxygens. And so how many oxygens do I have on my product side now?
Well, there's 2 on the CO2, and now there's 2 on the water.
So how many total is that?
4.
4. See, this is why we wait till the end on our oxygen. Our oxygen is now way easier. What do I need to do?
Just put a 2.
Just put a 2 where?
In front of the O2.
In front of the O2. And so now I've got 4 oxygens. Now does everybody happy? Everyone matches?
Everyone
Awesome.
matches.
All right. Our next guided practice. We're going to take sodium chloride. What's sodium chloride?
Salt.
Table salt. And we're going to break it down into sodium metal and chlorine gas. All right?
Which would both kill you.
Which would both kill you, yes. All right. Not so good on popcorn. We're going to start with our wrap.
Yep.
Okay? So what atoms do I have?
Na and Cl.
Na and Cl. Okay? My reactant side, how many NAs do I have?
1.
Chlorines.
1.
Product side.
1. And 2.
And 2. Okay, so what's the only thing that doesn't match?
Cl.
Cl. What do I have to do?
I gotta put a 2 in front of NaCl.
Gonna put a 2 on our reactant side. What does that give us?
2.
2 Cls.
But I have 2 Nas too.
We also have 2 NAs now. What else do I need?
I have to put a 2 in front of the Na on the product side.
Gonna put a 2 in front of the Na on the product side. Now does everybody match?
If you change it.
If I change my products, yes.
Yay!
All right. And our last guided practice problem. So this looks kind of scary with all of our letters, but what do we notice? So we've got ammonium hydroxide and sulfuric acid and ammonium sulfate and water.
Yes, we have the NH4. That's the same on both sides.
So we can treat it as one
It's a polyatomic.
single polyatomic. All right. Anything else that looks the same on both sides?
The SO4
The SO4. So
stays the same.
SO4 stays the same. We've got sulfate on both sides, even though it doesn't sound the same.
That's okay.
Anything else that looks the same on both sides? This one's a little harder to see.
Well, the H's and the O's, but they're all broken up.
Okay. Actually, we could rewrite our water as H and OH. So our OH actually stays the same on both sides. So we can treat OH as one thing, And then what's the only thing that's a single?
The H.
The H. All right. So now, how many NH4s do I have on my reactant side?
1,
How many SO4s do I have?
1,
OHs?
1,
H's?
2.
2. Okay.
And then
Product side.
2,
Okay.
1, 1, 1.
All right. So what doesn't match?
The H's and the NH4s.
Okay. So which one do we want to fix first?
NH4.
NH4. So I've got 2 NH4s on my product side. What do I need on my reactant
I
side?
need to put a 2 in front of the NH4.
Okay. And then what? So what does that change?
That gave me 2.
That gives me 2 there. What else does it give me 2 of?
It gives me 2 OHs.
Gives me 2 OHs.
Other side.
Yep. Thank you. Yes, if you change it on the wrong side, it will make your life way more complicated than it needs to be. I have done it. All right. So now what doesn't match?
The OH and the H.
The OH and the H. What do we need to put on the product side then?
Put a 2 in front of the H2O.
A 2 in front of the H2O, because that actually takes care of both. It has our H and our OH.
Yay!
So now everyone matches, and we've got everything
Everybody
balanced. So make sure you are following the law of conservation of mass, which means what?
Nothing can be created or destroyed.
Nothing can be created or destroyed. So any atoms you start with, you have to end up with. You have to have the same number on both sides. And what's the only thing we can change?
Coefficient.
Coefficient. So put big numbers in front. Do not touch the subscripts.
Don't.
All right.